Okay. So just now I give you the overview of the HLT. So yeah. So I will go through the bolting. I think probably after I finish the bolting theory, we head off for lunch, and then we come back. I try to finish off the talking. Then 1:30 because Mirage Daniel will be covering Mirage at 1:30. So I think we have a early lunch. We come back, and then I'll continue with the talk and tension after Daniel's session. And then because I have a call at 3 o'clock, so maybe 3 o'clock Sean will guide you on the hands-on. Then I'll come back and then finish up for the training.
Yeah.
Yeah. Okay, so I hope you the session just now. I think should be very helpful for you for the HLT, so you get a better understanding of the bigger products that we sell on the market.
Solutions provided
the
to
project.
customers.
Yes, correct. I think probably you might encounter some this kind of opportunity because you are more into the manufacturing plant, so you will most likely encounter customer moving big equipments, maybe things like CNC machine, genset or whatsoever. Then that will require more of the HLT products. So I think you will probably get encounter opportunities like that as well. Okay.
Yeah.
So next up, bolting. Okay, so what I'm going to cover to you is I'm going to cover some basic on the bolting theory, what bolting is about. Then the next part I'll cover the bolting on dogging and what's on the tensioning.
Yeah.
Alright. So let's keep this up. Okay, so this what we're going to cover is what are the joint types, the flange, clamp, gasket, fastener type, standard. The gasket, what's the gasket, what's the bolt and flange stress, what's control bolting, and what's the difference between torque and tension.
Yeah.
Right. So what's the difference between a bolted joint versus a welded joint? Okay, nearly all the process plants in the world are either welded joints or bolted joints. Okay. If the bolted joints are given the same importance and quality of assurance required in welded joint, right? The bolted joint works the same as welded joints. Okay. So this is what I call a welded joint and a bolted joint. Okay, this is bolted joint. Okay. So it will work the same if the bolting integrity is ensured. Okay, so this is a bolted joint. So the main component of a bolted joint is flange, okay, fastener, and of course in between the gasket. Okay, so this is very important. The purpose of this component, right, used correctly, is to join two pieces of pipeline together without any leak on the contained product. So if you see leaking, that means most likely the joint is not maintained. The joint needs to be maintained so that they ensure there's no leaking. Otherwise, it will be very disastrous, especially if it's there's pressurized material within the pipeline. So there are two common types of bolted joint. Okay, the type with the seal type, that means the joint with gasket, or there will be pressure vessel at the pipeline. Okay, and mechanical type, that means joint without gasket. That means there's no gasket in between the two joints. That means there's no structure, foundation, crane, wind turbine. So these are the joints that you might encounter also. Okay, so there's very no structural joints. So when we talk about joints, right, it's not just about pipeline. It can be structural as well. Those like foundation joint, even like all those crane, right? These are mechanical joints. Okay, so that will have that usually you see that in equipment, like those mining equipment, dozer and stuff. So you see those kind of joints. Okay. Mechanical connection are straightforward, rigid joint clamp. Whereas sealing application requires the effect of gasket to be consideration. So again, there will be those mechanical joint, those with sealing, right, will have a gasket in between to ensure that there's no leakage out. Okay. However, in all cases, right, whether it's sealing or mechanical type, it's important to ensure that the correct load is applied to the joint to produce an effective load clamping force. That means you need to ensure the load on the joint is correct. Too loose Not enough, you leak. Too tight, you might damage the gasket or you will damage the flange. Okay, so you must ensure the correct bolt load is applied. Okay, the bolt clamping force, there's a difference. For sealing application, gasket compression, there will be internal forces and external forces. This to prevent leaks. Mechanical is rigid, it's hard to join. So, main external force is to prevent the joint separation or bolt leakage, fatigue or nut shaking loose from bolt in vibration application. Okay. So, clamp force, that's this actually this that's the difference between sealing and mechanical. Okay, there are I told you there are French standards in this world that most pipeline or the mechanical joint comply to this international standard. SME, API, NOSOC, GIS or Australian AS. So most design in the world comply to this standard. So if the worst part is when you will find a pipeline joint that does not conform, that will be a big headache. Okay. Worldwide there are at least 20 French standard. It's possible to have different standard on the same system. It's dependent on where the customer buy or the designer is from usually. Yeah. So you might have different standard on the same system, so you review each joint independently. If the flange does not belong to any of the standard, then they need to be handled differently and carefully. Especially this I encountered a few times, those stuff from China. China those type of some low cost country, I mean, equipment, usually they don't conform to any standard. That's where the difficulty comes in. You need to guess, do some guessing in a way to see what type of flange type or what type of joint type and do some assumption. So that's why low cost equipment, yes, they might be cheap, but they don't follow a certain standard. And you have no idea how to make it. Okay, so common flange type, right? We have the well neck type, the blind, the swivel rings, okay, and also this alignment flange, the smart flange, mechanical connector. Okay, there are many types of flange type in this market. It could be a custom as well. So whenever you encounter a flange, right, a joint, flange type joint, it's always good to ask for more information from the customer. What type of flange is it? If it's possible, if it's possible, provide the drawings. Then that will help us identify the type of flange, or if not, based on the flange and see how our tool can fit onto the flange. So therefore, I would always recommend especially for projects like critical projects, if possible, get the drawing from the customer. Okay. Flange faces. There's a flat flange face, flange. That means a flat, totally flat, just joined together. Raised face flange. That means there's a step up, raised face. There's also a ring type, RTJ. There's a groove here to fit a sealing ring between the flange. And a speaker type, okay, of flange to one have a step down and the other step up. Yeah. Okay. So the gasket contact area will be different for different configuration. Okay, because with different sealing, gasket sealing stress and of course different workload requirement. So the different type of contact area, you probably need different sealing stress and then of course different workload. So your setting of the tool will be different from each flange type. So if the customer don't tell you what type of flange, it's very difficult for you to advise on what type of tool to use. But usually, I would say the manufacturer or the designer of this joint will tell you, will advise you, provide information such as a bolt load to apply. Okay. If not, then this information will be provided and we have to work out some calculation to determine what kind of load is required. Okay, so but for this to happen, there will be a lot of information, details will be required. Okay, yeah.
So in all kinds of cases, the bolt load is provided by the
customer.
designer.
Yes, correct.
customer.
Usually that will happen. Usually that will happen from especially those pipeline, those chemical plant. Usually they will have such spec available. If they don't have, then it's then we have to do a lot of calculation. So we need to know all this information, measurement, the design standard, the 2 feet, the dimension. So this have to be provided in order to do some calculation and determine the type of boat. So, yeah. So
Because in some cases for the outside factories
They don't
after
know. Yes.
fabrication and contractor finish and they
leave.
such as 5 years, 6 years, maybe
Yeah.
10 years
Yes,
later,
correct.
so lots of documents.
all gone. So we encountered that. I
How
know.
can we know that exactly?
Yes. That's why we all these things are not provided, then we will need to do the hard way lah. Measurement and of course photos and provide us with more information. And of course we have to put some disclaimer also. As in, yeah, this is based on their information provided. And then besides this we cannot 100% guarantee.
Yeah.
So
Yeah,
a lot
but
of-
just advice
Yes, we
and
can
recommendations for the customer they can know
Correct.
and apply. But we are not sure, we not guarantee for us
Yes,
information,
correct.
but based on customer decisions.
Correct. This will be based on what they provided because it's very difficult for us to. I mean, things like material was also need to know. This is all based on what customer provide to us. Yeah. So if let's say we're going to advise on something that's totally unknown, then you have to make a lot of assumptions. Yeah. Okay. So we have also things. I mean, there's this kind of clamp connectors, 4-bolt 2-piece clamp connector in the market. For this type will be dogging will be preferred due to the 2 feet. Okay, usually with dogging, and of course flexibility and time concern. So the method right of whether it's dogging or tensioning, a lot depends on what type of connection is on the joint. So there are different type of clamp connectors. So these are pretty much the standard in the market. So if you tell us it's a grade of flange, we have pretty much have an idea what type of connector we're looking at, tech law, less than. Okay. So the boat load and component are not interchangeable as they go. So it's not like you can change the boat load because it's very specified. So if the customer is using this kind of standard clamp connector, yeah, we need to know the brand and what type of maybe what type of connection it is, then we can advise on the boat load.
Yeah.
Okay, so this is an example. Okay, clamp connector,
Clamp
back
connection.
flange, and side flange. Okay, so the different type of
Connections.
solution.
AC plate. Yeah.
Yep. And then side, vice versa.
Yeah.
And technical support, technical. Okay, so this is an example. Alright. So there are different type of gasket type as well, with a spiral gasket, this set, RDJ,
Ring.
sealing ring, and profile. So there are different type of sealing type, gasket type for joint connection. So these are just some of the examples. Okay. Now fasteners. Okay, this is what we'll be turning on. Okay, for the boat, it can be metric and imperial type. Okay, usually start with 2 nuts, or start boat with 1 nut, or mechanical boat. Okay, mechanical cap head boat. So these are the different type of fastener that's usually common to the market. So we also have encountered they are just round nut as well. So it really depends on the design and what customer is using. So we need to know things like the tread pitch, the pitch, what type of coating. The type of coating will also affect the boat load as well. What type of load top we are using or tension. So things like coating, material grade especially, you need to know the material of the fastener. Okay.
So the coating also.
Yes, coating also affect.
It affect with what kinds of top brand
Yes,
we
correct.
select.
Correct. The apply of amount, yes, the type, amount of top that you apply, because the amount of top will determine what the model of the top range you use. Okay, so for nut, the standard hex nut, AB hex nut, round nut, material grade, so different type of nuts to use also. So washer we need to know the dimension and the material grades because some customers they use the nut as a washer. This will also affect the tool fit because when you put a washer there, the profile is raised. So whether it can our tool can fit in there, we also need to know if they are using a washer. Okay, so these are the there's a lot of details required when we advise on the tool. It could be a custom design. Okay, you see a fastener can be a custom design. So we also encountered some such a design as well, a custom. Especially this usually happens when you come to equipment. Some equipment that custom fastener, so it's a little bit more complicated because different section you cannot do on the togging. You might have to do apply a different load calculation, put load. Otherwise, it will affect you neck the fastener if tool is too high. Okay, so it really depends on the design. So what is a bolt? Okay, so a bolt actually behaves like a spring. Okay, it's actually follow very much on the Hooke's law. Okay, so when you do a togging or stretching, you will go with the elastic range first. Then when you hit the plastic range, that's why it will start to deform. Then of course when the bolt failure, when you tensile bond, it will snap. Okay, so basically you follow the Hooke's law. Okay, so it behaves like a spring. When you stretch the string too much and reach this tensile bond, that's where it will snap. Okay. So when the bolt, what happens when the nut is tightened? So the bolt, what happens when the nut is tightened is actually stretch this. Okay, the bolt stretches, and when it release, it returns, try to return, so it creates a compression load. Okay, so it's like a spring, which you pull, then release, it springs back. So this is where when you torque, it actually stretches the bolt. So when you finish torquing, the bolt stretch springs back and create a compression load on the two joints. Alright? So what happens when you under tighten? Okay, the bolt becomes loose due to cyclic load vibration. So you know when the material pass through by 9, it will create certain vibration as well. And of course, geothermal, the ground also will create certain vibration. All equipment moving around create vibration. So it will come loose if it's under tightened. Okay. When it's under tightened, because it's loose, the sealing face surface become damaged because of vibration. Okay. So there will be no classic compression because it's loose, so it will leak. What happens if over tightened? You create a neck, you neck the fastener, over tighten, stretch, and move out of the elastic range. Also at the same time, because of this force, you create a movement here and cracks the flange. Okay, and also because this the flange rotate, the whole thing moves and you create a leakage at a certain point, fissure at a certain point. And of course, if over compression of the gasket, it damage and you damage the gasket sealing as well. So when you are under tighten, it's also not right. Over tighten is not right. So you need to find the correct load so it falls within the range that it will not create such a situation. So for bolt load, what we're talking about, we are trying to find this range here. Okay, this one is over, this is under. Okay, so we have to find somewhere between this. You have to fall within this range. Okay, so that you will create a correct bolt load and make sure the joint is correctly sealed. Yeah, okay, so what are the factors that we need to consider when we do a bolt load calculation? Okay, we need to know the gasket compression tightness factors. We need to know the strength of the flange and the bolt. So that's why we need to know whether it's NSI, API, the flange, the bolt type, whether it's the grip of the bolt, the nut, whether what type of coating. Okay, and of course we need to know the force, if possible, then know the force that will tend to force the flange. What type of material is going through, what type of pressure within the line, and of course there will be both loss that may occur during process, as for example if it's a high temperature, okay, or external forces that may prevent. So that if let's say there are forces stretching the pipeline, these are things that we need to know. So the boat load is the upper portion of boat load range that enables sufficient boat load to be retained after the anticipated loss. So take note there will be losses during the certain process, like especially for toggling. There will be a lot of boat loss because due to things like friction. So later I will cover on the boat toggling and you understand what we mean by the loss. Okay, so what you apply, if let's say you apply incorrectly or you did not apply things like lubricant, you're actually losing a lot of force due to because you need to overcome friction and stuff. So that's why you might not get the correct load if you are not using the right tool and not using the right lubricant. Okay, it will affect greatly. Okay, so what we mean by uncontrolled bolting? Okay, a lot of end customers do not understand toggling. They just
Normal, it's
whack.
very normal.
Yeah, very normal. Just just whack and just use a bar. Yeah, this is very normal. Okay, so uncontrolled patterning is performed by flogging, hand spanner, impact wrench. So if still not tight enough, they put a bar, extend it, and just whack until it's tight. They feel it's tight.
And the hammer also.
Yes, hammer also. Yeah, right. So you do not, okay, it's not, the equipment that you use is not calibrated, you just whack. So how you determine how much force on your hand, you don't know. Okay, there's no procedure. It's just based by feeling. You just feel, oh, until you are tired, that means it's tightened. That's not the way. And no safety, because you whack, you might damage the tool. The tool is not just if you whack and then the hammer flies out and hit someone, it's not safe at all. It's not accurate. You whack, but you might whack at different angle. You don't know how much force you are using. It's inconsistent. You have no control. You don't know how much you cannot control how much force. But how much force you are controlling. You don't know. No training, no competency, and no quality. So this is what happens when there's uncontrolled bolting. Okay, so what we mean by controlled bolting? Controlled bolting, it means the operator, the person who's using the tool, doing the job, is trained, is prepared. There's a standard, there's a procedure to follow, and the amount of force event is based on a calculated result. Okay, so we have different tools that will help to achieve this process. Okay, and aid the user in providing an accurate load on the joint. Okay, so things like no-torque multipliers is based on there's a factor to increase the torque, and this based on we can calculate based on the tool specification, the input and output. There's a ratio based on that. We know based on the torque wrench, the manual torque wrench. This can be calculated. Things like pneumatic torque wrench, we can set the input air pressure, and then of course from there we calculate up and output torque. So we have pneumatic torque wrench. Things like a hydraulic torque wrench, we can set the pressure of the pump. We can do a torque verification using a calibration system. We have calibration cert. So based on that, we can determine how much torque output using the torque wrench. We have a torque checker also. This can help us verify the torque before we start the loop, so we know how much torque we're actually putting into this joint. And of course, we have things like hydraulic tensioner. Hydraulic tensioner is pretty much works like a hollow cylinder. So we know pressure. So definitely with the effective area is to cover. We know the force apply. Okay, pressure equal force of area. So we know pressure, we know effective area, we know how much force is applied. So this is very straightforward. tensioner. And of course we have more advanced tools using ultrasound, like a bone monitoring system. This is using ultrasound to like A scan, B scan, determine based on the result, we know estimate how much force is in the joint. So we have these are things like Bosco Pro and Ultra from Hydraulic. Okay.
Excuse me, for this is a bolo monitoring
System.
use of ultrasound.
Yeah, something like this. Ultrasound to do like V scan when we put a scope there and the sound feedback. We know based on the material, we can calculate the travel. Based on the frequency, and then you can based on that we calculate.
But then this the head has one.
No.
It can hear by itself.
It's of course
it can receive by itself.
Yeah. Ultrasound. I don't have much information on this because this is from a third party. I changed the hypertype. We don't really sell many of these because it's such product actually the market is quite such product. But although there's that many of such product, whether the user not going to use, that's another thing. Okay.
So excuse me, hydraulic top brand just put input
yes,
the load and cannot control and cannot know exactly is this correct both load or not. But the checker can
correct. You don't
have
know
a feedback sensor based on the ultrasound, blah blah.
Yes, correct. So you have to 100% verify. Then of course you need to use things like ultrasound, or you probably need to use the best way is to use the top range, of course, with of course transducer to verify whether the load is correct. A second, the final check doing that way. That's what you usually practice in the industry. Okay, so torque versus tension. So just as I mentioned, that when you're using torquing, so what happens is when you torque, right? On the fastener, the nut, when you torque, you are torquing against the surface of the joint.
Yeah.
So there will be frictional loss because you need to overcome the friction of the joint and the nut, and also the thread against each other, the nut. Okay, so these are what I call you need to the torque, the force is the force needed to overcome this friction. So what you input, the input force, if will be a lot is used to overcome these frictional forces and not exactly applied to the load. Okay, so the frictional loss during fault I consider more inconsistent than the more visible loss during boat tensioning. Because why? Because boat tensioning, what are you doing? You are pulling the boat, the stud, using the adapter. You are pulling the stud, and there's no frictional. Okay, because you are pulling. Okay, so there's no frictional, there's no friction loss.
And the friction between the surface also.
Yes, correct. There's no friction between surfaces of the nut and the joint. So tensioning, there's no frictional loss. Okay, so that's a big. That's why some application tensioning will be a better option as compared to torquing. But then of course there are things that need to weigh out because you know what type of force you want to achieve, and then whether the space is enough, because certain application there's limited space, so a tensioner cannot fit in. And then of course cost as well, because tensioning can be a lot more costly than torquing, and of course the things like time as well, because to set up a tensioner it takes a lot of time, whereas torquing can be a lot quicker, and of course budget because torquing, the torque range can be used for this, can be used for different kinds of range, whereas tensioner is specific to that boat type.
That kinds of bolts and correct only is
correct.
should look like suitable 100%.
Yes,
for
correct.
this.
You have to because
Not-
it's size configured to that tracks and size and so it's you have to weigh out which is more I would say more suitable for that kind of application. Yeah.
Look like tension look like pull
Yes, correct.
the bone and lock nut.
And
Yes.
turn a lot
Correct.
by hand.
By hand,
Yeah,
yes.
yeah.
So it will because when you do such an application, you need a long start,
Yeah.
and then not all places have that kind of space allowed. You see.
Yeah.
So that's why it really depends on what type of application. Yeah. So and then customers choose between tensioner and torque wrench. Yeah. So it really depends on the condition at that point of the application. Yeah. So usually the customer, I mean, if it's a maintenance job, I mean, usually in the plant that's been around for a long time, they already know what they want. Whether it's a matter of choosing which brand and to do. It's more of those new equipment, maybe a new plant, new equipment. Then probably have figure out which is the better option. Yeah.
So this is tensioner is normally is more special than torque. Torque wrench.
No, I would say it's special or it really depends on what kind of joint we are looking at. Okay, so if let's say the joint requires also depend on the force load as well, because tensioner can go up much higher, and then of course the 2 feet as well. Because let's say if the joint, the flange, right, there's a lot of some of the joint flange, right, we have welded parts and which may interfere with the fitting. It cannot fit, the tensioner cannot fit, then you no choice have to go for a torque wrench because the profile is smaller. Or if the stud is not long, it's too short, then the tensioner cannot fit in as well. So you have to go for a torque wrench. So if the force required is too high, the torque wrench cannot be able to achieve, then probably have to go for a tensioner. So it really depends on the condition. I mean the factors of the joint. Yeah. So there's no right or wrong whether it's a tensioner or torque wrench. So it really depends on what can fit. As
So
well.
that's the main decisions. The key point to select what kinds of use of torque wrench or both tensioners is the
What kind of joint?
kinds of choice
Yes,
and
correct.
space enough for
Precisely. Yes. Correct.
doing.
So if we are not talking just about pipeline, because also our equipment, for example, in the crane, whether it's using torque wrench better or using tensioner better, also depends on what type of space allowed, and what type of if the stud long enough or not, whether to do the tensioning or do the bombing. So it really depends on what kind of I mean what the condition that the factors there on the joint. Yeah.
But normally say if condition is suitable for both sides of solution, so normally somebody is familiar. So that's why torque wrench and tensioner. What is more expensive?
Of course, if let's say the customer has little budget, then of course a cheaper way would be a torque wrench lah. But also it depends on what type of time required. The time. If the customer has time to
Torque wrench is
to
faster.
torque wrench maybe
tension.
will be faster because if you use tensioner, cannot be one tensioner to one point. He has to do I think the how many days to get it right, and it's very complex because you have to do a lot of detailing to find out.
It's belong to the situation.
Yeah, it's really depends on the situation and also situation and budget and the timeline. The time, how much time they because usually, for example, I'll give you an example. Usually for like let's say plant shutdown, they need to do the maintenance work during the shutdown process. Usually they will engage contractor to do the pipeline maintenance. They only have a short window, maybe 3 days. They need to finish everything within 3 days. So usually before they do that, they will plan out at least 3 to 6 months before that they need to maintain, and that's where they will need to 3-6 months before they will need to buy the tools and to prepare and stand by to do the job. So at that point in time, the person who plan the maintenance will determine whether to do tensioning and torquing and to source the tools accordingly. This is usually what will happen. So the person will usually a contractor who use the tool, they will know whether they want to buy orange or tension. So usually that point they will know. Those who very what you mentioned, they don't know, they don't do straight away. Then most likely will be those equipment supplier. Those like crane, dozer, one-off, they don't know what to do, whether it's a torque or tension. That's where they probably need to find out more details. Usually they will move towards torquing because it's just point by point kind of fastening or loosening. You don't really see much of tensioning in those type of equipment maintenance. Usually with torque wrench.
So that is selection between the program now both tensioner. What is have bad impact to equipment?
No, there's not. It's always positive. There's no bad impact because what they're doing when you use tensioner or torque wrench, you are using controlled bolting. So it's definitely a better one than flogging, the manual, those that are uncontrolled. So the thing is the user customer to determine whether using a torquing or tensioner is more cost effective. It's more, I would say it's more cost effective, and also whether it really time is of the person, because they want it to be fast. There's a lot of ways to do. If you want it to be fast, right, they can buy 4 torque wrench and operate all 4 at the same time. That will be very fast. Or whether they want to do 100% torque of the one torque tensioner to one start. That one also can be very fast. So it really depends on the kind of budget or the kind of timeline they are looking at to maintain the tool. Okay, because for tensioner the setup is very much simplified, very simple. Just put a tensioner there on the bar, but torque wrench. For tensioner, you need to set up, tighten, mark it 100%, 200%, and the setup you need to connect many hoses and things like you need to know the sequence, operation sequence, method of statement. How much to do set first, 100%, 50%, 25%, first pressure, second pressure, all these you need to know. So it's not so straightforward. So the time to set up a tensioner, it might be longer than the torque wrench. So it really depends on what kind of method the customer wants to go with. And then from there they measure whether the time taken versus the cost, which is more important to them. And then from there they make a decision whether to go tensioner or torque wrench. So that stuffing will play a part into that decision. Okay, so for me to say whether which is better, I cannot tell you because the decision point comes from the customer.
Yeah.
So it's for our part is for us to recommend what meets the requirement, whether tensioner or torque wrench. Which one meets the requirement? Cost-wise, we could then whether which one they will take. It's not up to us to tell them which is better. Yeah. Okay. So default tension is more accurate, of course, on conventional torque tightening, unless the torque tightening is used with a load monitoring system like ultrasonic. But of course, low tension is the preferred method of tightening due to accuracy and ability to load the flange and gasket uniformly. But like I said, it's very dependent on the tool fit. Okay, torque tightening is usually suitable for smaller bolt diameters. Small short grip length means the stud is very short. Okay, or bolt stretch is very close, quite close to new strength of the bolt material. So bolt tightening. Okay, so any questions regarding bolting theory? So one thing I need to highlight is if you are not sure about the bolt tightening process, right? We do provide the bolt calculation, but of course not free because we will run through a detailed information. But of course, if the customer needs to do that kind of detail, okay, and we can work together and see how we can help the customer. If it's a project, a big scale project, of course, providing calculation of fee in order to get the project. That's one way you can do to help customer and win the order. So, of course, but it's just one joint, right? But of course, we don't give for free lah. It's really depends on the situation. So bolting is not something difficult. A lot of what we notice in the market, I mean the region for distributors, a lot of distributors are very afraid to touch on bolting.
That's what.
to sell bolting tools.
Yeah.
Okay, the reason being because it requires a lot of information. Okay, and a lot of them are very afraid. So, but what I tell them is always don't be afraid to learn this. When you encounter this one, let us know the information. We will try to guide you, distributors, salesmen along how to sell. Okay, we have hydraulic services here, so they are known in the world for their expertise in joint integrity. We have the calculation, we have the joint calculator as all this software to guide us along, to help us in improving what type of tools to use, what type of boat load to use, and all this. We have all these tools to help us to convince the customer. So just don't be afraid of getting inquiries for this. So, but the thing is, coming to this also, we also need the right information for us to help the customer. So when you encounter this one, if you are not sure what to select, please reach out to us. We'll guide you along. Okay?
Our customer have a lot of training to sell the hydraulic training for them. So after training, then we buy the Enerpac.
Okay. So now that's the thing. Okay. So for hydraulic, we do provide training.
Yeah.
So yes, we offer two types of training.
Yeah.
Okay. One is the hydraulic training, which outside there.
Yeah. Over there, right? Over there. Yeah, I see.
Yeah. Hydraulic training, that is we can deliver it here or deliver it on site, provided the customer meets certain requirements.
Okay,
That's
okay.
hydraulic training. Yeah. But we have ECITV training as well. ECITV, that's a global recognized training. It's a world certified globally. Okay, but the training can only be delivered in Singapore. Okay, no, I will say Singapore. To be exact, is ECITV approved site. Okay, so for example, if because our office here is ECITV approved, our Australia office approved. If the customer can provide ECITV approved site, then our trainer can do the training over there. Okay, so we will have to send an ECITV approved trainer. And the trainer will be good already, so we will send someone from Australia to do ECITV training. Okay, so we have these two types of training to so-called certify the customer's engineer or technician to carry out certain job. Okay, so we do have that kind of training. So also this is about the bolting theory. I think there's no for I think we better go for lunch.
Yeah.
And then after we come back, I will carry on a bit of talking.
Yeah.
We shall come back because today we still have a Mirage training at 1:30. Yeah, so let's go for lunch first.
Oh, excuse me, you said about EPRT training.
ECITV.
How to pronounce?
C for car.
C.
I, then T.
T. Yeah.
ECITV. B for bus.
B for bus.
TB.
ITB.
Yeah,
okay.
ECITV.
ECITB. B.
Yeah. So it's
This is a global.
yes, it's a global standard.
It look like a global certifications for
those kind of joint integrity certification. So the training will involve. There's a different kind of training. There's talk and tension training. There's talk and tension training. So we can certify the person who go through this. to perform a certain job on site, and then this is certified. The person will be certified globally by ECITB. We are certified to deliver training, so their record will be on the ECITB global register, and then if they clock a certain number of a job within a year, they can come to us this is for the first part, the theory training, theory hands-on training, and when after they clock 1 year of a job, they can come back to us and do the so-called on-site certification. Then there will be a second part of training. So once they clock, they can go out there and tell people that this person, I can do this job, and so it depends on requirement. Because some sites, especially like I think I don't hear so much in Vietnam, but in some sites like in Thailand, especially in Thailand, the plant will require the contractor to be ECITB certified before they can do the job.
Visualize the importance of the first job on the
correct. Because those are petrochemical plant, right? They will require their requirement for any contractors or any workers to be ECITB certified before they can come into the plant to do any job. So there are some such requirements out there in the market currently. I think Thailand, not so much in Vietnam. I don't so hear so much in Vietnam, but more in Thailand, Malaysia, and Singapore.
Could you please tell me the contents of the training? Hydra Thai training is fee.
I will ask Elena to send later when you talk to Daniel will be here to conduct the Mirage training because he's also taking care of the Hydra Thai training, so you can ask him to send you the details later. Because the ECITB also cover machining training as well. Yeah, machining training on ECITB. So
does a distributor can sell a Hydra Thai training to the customer?
Okay, for this one you probably have to work with Daniel. Then later he'll be here because this one a bit more complicated. So it was sensitive, a bit more complicated because there are certain requirements to fulfill before we can deliver training to customer through a distribution channel. Because especially for ECITB, because the site is not ECITB certified, we cannot deliver training. Yeah, the ECITB don't allow. They have a lot of rules. And then if it's a hydraulic training, whether the customer can accept hydraulic training, because although we are known in the world, but whether their customer can accept, that's another question mark. So there are certain conditions to meet with. It's not like we want to deliver, means we deliver, because we need to one class we also have restriction. Like CITB, the class maximum 6 trainees, no more than that. So if the customer has many trainees, then we have to split to many classes.
Yes.
So and then that would be a bit, that would be costly lah. So like hydraulic training also have a cap on number of trainees per class. So we have encountered deliver training over the most like 2 weeks everyday class. So it's a little bit more complicated. So there's a lot of things to